the steady state regime and in the transient regime. Okay. Then, I mean, we started cooperation about 30 years ago. In fact, as we can say, I mean, as people have explained, I mean, there was a change, a gradual political change in the climate in the early 80s, and there was an exploratory mission in optics in 82, and then an international program of cooperation, scientific cooperation, started at the end of 82. It was led by Claude Cohen-Tanucci from École Normale Supérieure and Umberto Bondi, who was at that time at PUC, Rio de Janeiro. So I think it was the start, and I just want to show you, I mean, some historic of this collaboration, I would say, between France and Brazil in optics in general, and then particularly between the University of Paris 13 and Nord-Est. So it started as a program. PICS is Programme International of Scientific Cooperation. It has been renewed twice. The lab involved were our lab, laser physics lab in Paris 13, the Kastler Brossel laboratory in École Normale Supérieure, and the lab of quantum optics in École Polytechnique. And in Brazil, first it was both this physics department, I mean the optics part of the physics department, and also PUC in Rio, and later San Carlos came with Vanderlei Bagnato. Okay, the objective as given here, develop the cooperation. The themes were mainly laser spectroscopy, nonlinear and quantum optics, and later laser cooling. And the activity was mainly about short stay, and it was for scientific cooperation, and there was no emphasis on doctoral formation at that time. It came later. But there was some sandwich thesis starting. The final workshop was held in Rio in January 96. Okay. Then we have CAFES COFECUB, cooperation contract, renewed once. And in fact, I think there is another one starting now. In general, headed by Daniel Bloch in my lab on the French side. And it was involving the laser physics lab, and later two other labs in Lille and in Sophia Antipolis, south of France, close to Nice. And in Brazil, it was first a physics department here, and also the Université Fédérale of Paraíba in João Pessoa. It was clearly oriented toward Nord-Est and doctoral formation, and it was more interested in interaction of atoms and surfaces, non-linear optics in gases, chaos, and later orbital momentum of light. And then we have more scientific stay, and we have co-tutel or sandwich PhD thesis, a number of one. And here, I mean, I don't know if you see. I mean, there was one defense, co-tutel defense of Thierry Pastrade de Sinans, who was in Paraíba in João Pessoa that time. Well, I just remind the things that you may know. I mean, in some way, I mean, there was a context of Nord-Est. In fact, this presentation, I did it a couple of years ago in a CAPES COFECUB final meeting on this, and I think it was quite interesting. I mean, it was. I mean, this department is experimental physics in '71, and that's quite important because we have to know that before, I mean, physics was mainly theoretical physics for a very long time before, and now it's considered as it is at the top level with a strong mobility. And I remind some of the mobility of the student of the Université Fédérale of Pernambuco in Brazil and outside. And for instance, we had two former students, Marco Oria and Martin Chevrolier from our lab, former PhD students, which are now in John Pessoa. Claudio, Len, Cesar, who should come, I mean, as a mestrado here when I was here. And then he went to MIT for a PhD, and now he's in Université Fédérale of Rio de Janeiro. A particularly interesting diffusion case is Arturo, which is special because, I mean, first a thesis of troisième cycle in Paris, in École Normale Supérieure, then a PhD here, then a postdoc in Harvard, and also in the West. I don't remember where it was. Oregon, yeah. And then it's professor first at PUC and then finally at the University of Montevideo. And because of that, we have also a course agreement, try to have a network collaboration between Uruguay, Brazil, and France. I think it's quite important to develop network cooperation. Well, now I would like to enter in the detail and give you some of the things which happens. So the stay I did was the 10th stay where I came, I'm in Brazil, I came to Nordeste between 1983 and September 2010. And so I'm going to through some of them and discuss of some of things happens. First one, interesting, no? My first day in July 1983. It was quite interesting that when you are coming to the campus of the university in 1983, I heard that the campus was started, I did not know when it was started, but not very long before, I think in the end of 70s. But it was quite interesting to realize that the co arriving before us on the campus, you know. So when we were coming with Rios, I mean, I saw the cow there. It was, you don't need anything to cut the grass, in fact. That's quite interesting, no? And as we know, I mean, Rios has a particular way of handling with people and animals, and he is doing well. I should say that I remember arriving and disturbing a snake also in when arriving here. You see the type of and what I like quite well at that time is that Rios, I entered his lab and I was looking at, I saw some kind of tubes along the wall. You know, it was not nanotube at that time. It was more than millimeter tube. And Rios told me it's termites. You remember that? He has the termites going along the walls. I suppose it was cement termites, but it's quite impressive. And I have to say at that point that I have a first personal thought, you know. I travel a lot in my life. And up to this early 80s, I was making a difference between traveling when I was with friends and, you know, backpack and going to countries and traveling for the work. So, for instance, I've been in the 70s to Japan or to US, and I stayed in US. I mean, so, I mean, there was country where you are doing teaching and research, high-level research. But I was traveling a lot, and I was going to Mexico with a backpack. I was going to Southeast Asia. You know, I went to India, to Burma, all that in the 70s, or to Iraq, to Iran, I crossed the Iraq-Iran border, you know, in a bus. I went to Thailand, to Indonesia. But I made the difference between, I would say, developing country, you know, when I was backpacking and going for my fun and trying to see new people. And when I was moving for the work, for the job. And here, in some way, I was looking at the change. I mean, not the change, but something very strange. People trying to do high-level research in an environment which is more third world and developing country. And I think when you see that now and what you see here, you see the change. And it's quite important, I think. But because for me it was, you know, I have this kind of way of separating things. And it's bad, in fact. It was bad in my, but it was like that, you know, in 1980. I mean, you have time to change, unfortunately. Okay, so that's, then I think I need to, the chief of the physics department, I need to show him. That's in '86, the second time I came. And they are trying to make the CO2 laser working, you know. And yeah, okay, it was, you see that thing changed, but it was, yeah, it was a way, in fact, I stayed. I should say something for this stay. It was at the time in Brazil when inflation rate was 10%, not a year, a month, okay. And I was invited as an invited professor for 1 month. And I was supposed to arrive on the 1st of August. The reason is that I was heading the lab, and for me, the best was to leave during the vacation, you know, and I was taking, if I leave for 1 month in particular. So I did that in August, but I could not come immediately. And I think in the few days who I arrive, I mean, the salary has already declined by a few percent, you know, and it was a time of conto euro, no, where to keep the value of the I don't know if it was the Cruzeiro or the Cruzado, I don't remember. Anyway, that's okay. I continue the story. Okay, now I would like to speak about some. Stay when in 87 and 89, 91. So, I mean, Sergio show you a picture. I think we have to show the full picture with Sergio, Rios, Claude Cohen-Tanucci, and me. I have my mustache, as I told you at that time. And it was in Porto de Galinhas. I will show you another picture later, just to make the comparison. But it was interesting. Yeah, don't read the things. I mean, what I'm showing is that it's one of the first common publication. But it's interesting. This is the work done here, and in fact, I can say that. It started, I mean, on some things that we discussed, because it was impossible to get where we were doing phase conjugation. Phase conjugation is using 4-wave mixing. You know, you send 3 waves, and then a 4th wave is coming opposite. It's very important because it's wavefront reversing in optics. So you have many applications in technology, in laser emission and things like that. And they tried to study that at 10 micron in SF6. You have the type of, that is very small, the type of setup that you have, I mean, with a counterpropagating wave, a 3rd wave, and a 4th wave, which is emitted back. Then the problem is that it was impossible to observe the signal because of many diffusion of the return wave going through the waves that we were looking for. And I remember that in the discussion, I remember that Ted Hench, I mean, who got the Nobel Prize later, I mean, used the idea of vibrating one mirror in order to separate the diffusion from the real signal. And that was the way to get the signal. And in fact, because the year before we spent 1 month without getting anything, there was noise, and fluctuating noise. And this time, we have these nice signals that you can see, and we can observe the angular dependence because of Doppler bonding. I think I should not enter in this detail. Well, I'm wearing too fast, yes. This one, I think I have to say something about this story. First, it is in March 91. I came, in fact, end of February 91. I came the night where the embargo on the first Gulf War was finished. You know, there was an embargo towards Saddam Hussein because he has invaded Kuwait, and there was an embargo asking him to leave Kuwait. And the embargo was finishing on the 24, 25 of February. I don't know exactly. And it was very strong. I mean, for instance, all the Americans were forbidden to take the plane for several weeks. You know, I was organizing an international conference in France in Font-Romeu later in 91, and I had a committee, a scientific committee to discuss the program. John Hall and Ted Hench were part of the committee, and John Hall did not come. And we had on the phone, and in the phone he was saying things. He did not come because he was forbidden to leave the US. And that was because of this preparation of the war. So I took the flight, which was the Air France flight from Paris to Recife. At that time, there was Air France flight from Paris to Recife, direct flight, quite nice. And in fact, it was reminiscent of the Aeropostale when you have the, you know, going to Recife, then Rio, I think, then Buenos Aires and Santiago de Chile. I mean, the things which has been presented by Antoine de Saint-Exupéry. I mean, it's not known as the Petit Prince, but Le Petit Prince, but it's quite important. And so I came with this type of flight, and it was really the night where the embargo was finished. In fact, it was, I think, a Boeing 747, and we were 10 people in the flight. And they proposed me to upgrade me to a first class. That's the only time I went to the first class. Usually, you are upgraded because it's overbooked or things like that, but not because there is nobody in the plane. Anyway, so I came and I have a car, and this car, I think I have to say the story. This car was a car of a German guy who was employed at the French consulate in Recife. And this German guy was leaving for vacation, and he left the car to a French friend who has no driving license, and he was asking me, can you drive this car? So I drove this car, and I had some problem quickly because it was raining a lot. And I realized that when I was braking, stopping for a traffic light, the car was doing that, you know, in particular when it was a little bit wet. After some time, I look at the tires. You cannot see the tires here. But the tires, the surface of the tire was a perfectly flat surface, you know? Like, fantastic. So I say, yes, I was surprised from a German person to have this type of but we are in Recife, okay. And then I was coming, that's the picture, at the physics department, and I discussed with Rios about that. And Rios told me, yes, in Europe, you have good tires with the right asperities and things like that, but the roads are very flat. Here, the tires are flat, but the roads are like that. Well, that's, I think, okay. Continue. I skipped the 98, which was Capes Coffee Cube. I went to Jean Pessoa. That was my first visit in Jean Pessoa, and I saw Marc Soria and Martine Chevrolier. To come to the closure symposium of the World Year of Physics, and I think it was quite nice to have this closure symposium in Recife. For me, it has some meanings. I mean, the sense that the opening was in UNESCO in January, and the closure was here, so it was really has some meaning in the sense that physics is also important in emerging countries. I mean, it was still in emerging countries, and so. I have that, and there is one picture. So now I will come back later, but you have Claude Cohen-Tanucci, Sergio, Rios, me, and Serge Haroche. So, I mean, you can realize that things have changed. If you compare with that, it's not exactly the same view. 18 years between the two. The two events, not the same people. Hey, yes, it's clear that when you are here, you know, between the two, Claude Cohen-Tanucci got the Nobel Prize, Sergio was minister, and we did not do anything, Rios and me. And but I think it was a very nice closure meeting with presence also of Dan Kleppner, Mildred Dresselos, and other people. And I remember Jorge Tredice coming. You remember Jorge Tredice coming from, he was in Natal or something like that, and suddenly he came and he said, I am naked, I have nothing. There was, on the bus from Natal to here, there was a robbery, an assault, you know, with the gun and everything. So you have to leave everything, in particular his laptop. And I don't know, I don't remember how he made the presentation. Like that, yes, like an Argentine guy. And Jorge Tredice, it's interesting because later on, I discussed, Jorge Tredice was director of the INLN Nice, I mean the laboratory in Nice, Sophia Antipolis. And I discussed with some people in charge of security at CNRS. And they say, you know, we don't know about Jorge Tredice because he's losing very often his laptop. And the reason is that he lost, I mean, it was not a loss in that case, not really, but he lost a laptop in his car in Nice because he left it there and he was taken away. So, I mean, the safety person in Siena say, well, what means that? I don't know. I mean, I think it's pure coincidence. Anyway, okay, I continue where I am. Yes, I'm finishing the things. I mean, I came later to the symposium organized by Leonardo. Then the 30th anniversary of Capes Coffee Cube. I have to say that I just say that it was very sad because, you know, I missed in some way the plane going back from Sao Paulo, Rio, I don't remember, to Paris by 2 days, you know. And I knew people in the Air France plane. I mean, people from the Aimé Coton lab and things like that. Yeah. You realize, and Rios asked me to leave later just to take the right plane. Yeah. Yeah. No, I had to go back because of some friends. And the last one was things organized by the lab organized by Anderson. Okay, now I will say that there are other visitors. I mean, Daniel Bloch from my lab, Georges Camille, now is retired, Jean-Claude Keller. There are a number of people, but I could not go through all the visitors coming here. What else? I would like now just to give an idea of the type of the topics of cooperation that we had. One was I will say the start was laser spectroscopy and resonant for-wave mixing in gases, in particular phase conjugation. Then starting in 1987, I will come back on this because it's quite interesting. We started to observe, to do quantum optics studies at gas-solid interfaces and take atom as a quantum probe of surface, nanosurfaces, and nano-objects. And relatively recently, we started the study of spiral light beams and orbital angular momentum and the photon detector based on higher multiple excitation. I mean, what they are bringing on the view of this type of beam. I will come as we go through now the visitor in Villetaneuse, in University of Paris 13. Clearly, Rios came quite very often, but we have other visitors with more or less success, sometimes big success, sometimes less. So it started in '83, and but the '83 was really a visit to see the lab. And with Rios, we started to have a collaboration, common work on the phase conjugate laser phase conjugate emission via degenerate four-wave mixing, and also I will see later. I mean the Doppler-free evanescence spectroscopy. So this shows this work. I mean, the publication with this work, which is, I think that's the first publication, in fact, which is inside the cooperation. I mean, if we are not taking the publication of MIT. I think that's the first one, which is a phase conjugate self-oscillation in four-wave mixing. In fact, when you are doing, I mean, what was done in Villetaneuse at the laser physics lab was to do that in a vapor of sodium, you know, and Rios was there at that time, and it was the work of Pierre Simoneau, the thesis work, and it came very fast. I mean, because we have the right laser to do that and the things, and it was very, very fast. I mean, you stay 1 month and we got it. And after we have a follow-up with Gilbert Grimbert in INS, in the École Normale Supérieure, about the study of instabilities due to mirrorless four-wave mixing oscillation. And it was quite interesting. In fact, this second one, I mean, this instabilities, is quite quoted in, I mean, something like 150 quotation or something like that. It's not bad for this, particularly in optics communication. Okay, I came too fast. Then I would like to in the same time that when Rios was there, Rios was coming back from a stay at Ronchen lab. No, is that at that time? Yes. And he discussed, and he had some idea, and we discussed when he was there about making laser spectroscopy with evanescent wave in an interface. And it has been done when the seed came later in the lab, and we did it, and processes of atom on surfaces, and the time of, and in fact it was a work of Marco Soria during his thesis, later on, his PhD thesis, and it gives some interesting result. Now, for the chief, the chief of the department, Tabosa spent 6 months. 6 months as a sandwich thesis in 86, 87, something like that. And he did something like, this 4-wave mixing, but now it's no longer degenerate, it's non-degenerate multi-wave mixing. So you have to change the geometry, as you can see. I will not enter the detail. But what is interesting is that you can see that you are observing the Stark splitting, the dynamic Stark splitting. It was part of his PhD thesis when he came back here. This is, now I'm coming to Marco Soria. Marco Soria has spent 3 or 4 years in Villetaneuse and for his PhD, and he was mainly interested in the interaction, van der Waals interaction between atom and surface, and observed that by selective reflection spectroscopy. This is the publication, main publication of this thesis, and in fact, when you are doing selective reflection spectroscopy on a surface with a vapor, you are sensitive to the nonlinear index very close to the surface, and so you are sensitive to atoms which are in interaction with the surface. Just one thing to explain what is van der Waals interaction, because I think it's quite important. And it's a very basic idea that you are taking a neutral system like an atom, but you have fluctuating charges in front of a reflector of a surface, and each charge see an image, and so you have an interaction between 2 neutral polarizable systems, and this interaction, in fact, can be written as a function of the dipole of the system, and also of the response of the reflector, which is of the type epsilon minus 1 over epsilon plus 1. Epsilon is the dielectric constant of the reflector of the surface. This gives you a direct access to what we call a C3 coefficient, which is a coefficient of interaction between the neutral polarizable macroscopic system and the surface. In fact, it can be observed by selective reflection, but what happens is, what we did, we continue that in a very more idea is that if the surface is dispersive, it means the epsilon, the dielectric constant. The dielectric constant, it depends on the frequency. Then you may have, it does not work. Maybe I should take this, yes. Along the surface, you may have surface mode which appear. And if this surface mode oscillates at frequency which are resonant frequency of the atom, you may have a resonant coupling between the atom or the molecule and the surface. So you have a resonant coupling, and that's something that we started later with Feilash, Horacio Feilash from Montevideo. And it was his PhD thesis, and I show here the form as a function of the wavelengths of the response of the sapphire and the polariton, the surface polariton. And the way we observe that is by a two-step in cesium, a two-step excitation, and the second part we are observing the selective reflection on from 6p to 6d. In fact, if I show that, is that because Rios was present. It's work now. When we started the experiment, I mean, this shows the type of things that we are sending the two beam, and we are looking the reflection on the 876 beam. And as a function of the frequency, you can make a spectrum in reflection. And you see that the spectrum of reflection depends on the matter of the surface, either YAG or sapphire, and the modification of the position indicates this resonant reflection, and in particular, a change in the sign of the interaction between the atom and the surface, and means the van der Waals attraction is turned into a van der Waals repulsion. This was a presentation in France with the first presentation where we did not have all the interpretation at that time. Okay. I will not continue, but I mean, after we look at the dependence of the C3 coefficient, the coefficient of interaction between atom and surfaces, dependent on the temperature of the surface, and it was a work done with Thierry Passerat de Silence. It was his thesis work. That shows the variation as a function of the temperature of the surface of the C3 coefficient. I would like to finish on these topics by saying a few words about something we have started with Rios and also Vassily Klimov from the Lebedev Physical Institute. This is about the properties of Laguerre-Gauss beam and Bessel beams, which are spiral with orbital angular momentum, and the way to explore their properties by using specific detectors. And in fact, this is in Optics Express publication 2 years ago, and what we propose, it was purely theoretical, is to use a special type of detector to look at the shape of the beam. Here you have the electric field spatial distribution, and here's magnetic field spatial distribution at the waist, and you see all the very cumbersome figure, and that's for a Laguerre-Gauss beam which has which is of order 6, and I cannot. Order 6, and with angular momentum, orbital momentum m equal 2. And if we use a quadrupole detector, electric quadrupole detector, we have something which is quite interesting. In fact, depending on the excitation rate we are looking with this E2 transition, if we are looking at the m equal +1 transition, which is the one in red, you see that you have the maximum at the beam center, maximum of absorption at beam center, which is observed. If you are looking at the transition towards this magnetic level m equal -1, you have 0 transition at line center, and then it's increasing on the wing up to some point. But the radial distribution of the total energy is minimum at line center, and you see that transition rates are not following the amplitude. And that's normal in the sense that, in fact, when you are looking at quadrupole excitation, it's sensitive to the derivative of the electric field. So, and the derivative, the first order derivative is maximum at line center. Okay, just to give you, I had to stop at that point, I mean, about physics, and just to give you a view of what we are doing, I mean, the collaboration, what is on the way in the collaboration between Paris 13 and University of Federal of Pernambuco.